Oh, okay. All right, so there's a couple major things that we really want to pay attention to on this. One of the biggest things is going to be this part right here. We are really only using sine, cosine, and tangent when it comes to inverses. Now, when it comes to what possible values we're picking from off of the unit circle, okay, we're looking over here. Now, I would recommend getting your unit circle out when we start doing some of these problems because we're going to talk through them as we do it. Can I scroll so we can see some of the examples? You can color code them if you want. When we get down here, it'll make way more sense. All right, so write these two in your notes. It's way easier than it looks, so don't panic yet. No. So this all comes from the unit circle, all right, which makes life easier. Okay, we ready to actually do one of these? Okay, so first things first, I'm using sine, okay? So when I'm talking sine, what quadrants was I looking at? Look over here. So sine is looking between negative pi over 2, which is down here, and positive pi over 2. Why do you think we're only focused on quadrants 1 and 4? Think about the sine values there. They're positive up here. What are the sine values down here? Negative. Okay? So what we're doing when we're solving inverse functions is we're looking for what is the fastest way to get possible answers off of the unit circle. Okay? So, at what value for theta is sine a negative root 3 over 2? So where am I on the unit circle? 8. 5 pi over 3. Now, because 5 pi over 3. Because we're dealing in terms of negative pi over 2 to positive pi over 2, can you give me a coterminal angle with 5 pi over 3 that would satisfy our restrictions? So if I'm at 5 pi over 3 and I need a negative coterminal, yeah, just a negative pi over 3 to get me to here. So, equals negative pi over 3. I'm done. No, I'm done with that problem. Nice try. You're going to want more example problems for it. Okay? Now, if you notice on the second example, it now says arc sine. Is there really any difference between arc sine and sine inverse? No. It means the same stinking thing. This is still just sine inverse of 1. Okay? So it's just a real messy way of showing same thing, different notations. Inverse. Yeah. All right. Slightly. If I look at this one, does it help when I draw in the little circle and then highlight it? Okay. So I'm focused here and here. Where is the sign a positive 1? Pi over 2 up at the top. I'm done. Yep, that's the answer. So when we use inverse sine, what are we using it for? We used it on a proving task last week. It was to solve for the angles, right? Yeah. So anytime you're doing inverse functions, it's telling me what value for theta on the unit circle gets me this value. another way of writing it would be sine of theta equals 1. Tell me what's theta. Okay. Same crap, different format. No, so it's going to be a regular pi over 2 because I want sine to be a positive 1. Okay.
But then what's the arc for?
Inverse. It means the same thing. Okay. It's just different notations because some old dead dude decided he liked it this way and the other one decided they liked it with arc sine. Why did I go down here? So, yes, it's 5 pi over 3 on the unit circle, except I want my values to be in between positive pi over 2 and negative pi over 2, because I have that restriction on it. Okay? So, possibly. Yeah, you're going to have to memorize that. All right, so we are doing cosine now. So, take a peek at that little slippy-doo that I gave you. What quadrants am I focused on for cosine? 1 and 2. So if you look over on this, the little slip, and then you go down, so it says cosine, the range, which is the restrictions that I'm focused on, is between 0 and pi. So that is 0 here, all the way up to pi here. Does that make more sense? Yep. Yep. I know. All right. So, guys, where am I? I'm at negative root 2 over 2. So I'm over here, but what value is that? 3 pi over 4. Is that between 0 and pi? Done. And remember, the inverse of negative root 2 over 2 equals theta. The theta is the radian value.
Oh.
Okay? Yes. You'll find one in between those two constraints. All right. Yeah, the first one with negative, it's dependent more on what those restrictions are. So for tangent, what values do I care about again? Negative pi over 2 and positive pi over 2. What's that the same as? Sine. Now, real quick, kind of think about the tangent values. Tangent values up here are positive, tangent values down here are negative, right? Cosine values up here are positive. Cosine values over here are negative. Did you notice it goes for the two quadrants that are touching each other that covers positive and negative values right away? That's the easiest way to remember this. Okay? So, where is the tangent? What color do I want? Where is tangent going to be negative 1? 7 pi over 4? Is that between my restrictions? Nope. Can you give me a coterminal that is between my restrictions? Yep, negative pi over 4. Shh. Yes, this is all that it is. The restrictions are here. For arc sine, it's between, yes, here and here. 7 pi over 4 is not between negative pi over 2 and positive pi over 2. Negative pi over 4, which gets me to the same place, is. Because 7 pi over 4 assumes you've gone all the way this way. Negative pi over 4 just goes here.
So, like, this is the restriction given, but then it has to be within the numbers of those?
Yes. Okay. Yep. It goes straight down to it. Yes. All right. I got 2 more. Actually, I think I got a couple more. Oh, stop. This is not that difficult. There's been no math actually involved. It's just weird conceptually. Okay. Now try these. What is this blasphemy? Write it down. If you want to, you can. Nonsense, basically. Yeah, if you guys want to try it for a second, go ahead. You're getting toxic vibes. All right. So, shh, guys, remember I'm still recording, so people can hear a bunch of nonsense behind me. I was going to say, if I was watching the video and all I heard was my teacher like having to constantly remind people to be quiet while she was trying to teach, like I'd get annoyed. Seventh period, yes. So, real quick, what is the sine of 3 pi? 0. All right, so remember, you go from 0 to pi to 2 pi, all the way back to pi, I'm at 0. This is 0. So now, I have to find sine inverse of 0. Draw your little picture, and then what quadrants am I really focused on? 1 and 4. Now, where is sine 0 on my restrictions? 0. You're done. You could put it as 0 pi if you want. Yeah. All right, ready to do the one on the right? So, for this one, guys, we have to start with the inverse. Guys, can we quit being weird? Because I would really like this video to not be 30 minutes long for something that should take 10. So, sine inverse, I'm still focused here. Where is sine inverse root 2 over 2? Pi over 4. Is pi over 4 in my restrictions? Yes. So I'm good. So now I need to find what is the sine of pi over 4. Am I kind of back to the beginning? So, the one thing I want to point out is if you do sine of sine inverse, whatever you get here is your answer. Okay? Did it work the same way going opposite order? Sine inverse on the outside, sine on the inside. No. All right, so I wouldn't necessarily trust that I can just cancel crap out and be like, oh, it's 3 pi. That ain't gonna work. This one does. What? This? I'm saying this would be your answer. It's like, look right here. In theory, yes. We'll double check that. Nope. This will be on, approving task next week. Tomorrow, cosine and sine is 4 questions. 3, no calculator. The one on the back is calculator. And then tangent, cotangent, 3 questions. You do not get to use the little tables that have all the parent function graphs. You got to memorize them. Yes, you have to memorize parent functions. Pretty much, yeah. All right, I got 2 more. Last 2. Righty, let's go. Does it help going through and like working things in order of operations? A little bit. So, what is the tangent at 3 pi over 4? -1. So then, I've got tangent inverse of -1, except tangent has what restrictions on it? What quadrants? Yep. So, where in that red area is tangent a -1? Negative pi over 4. All right, ready for that last one? Now, this last one's not quite as bad. Well, mainly because we've already done this part, right? -1. So I'm really focused on what is cosine inverse of -1. What quadrants am I focused on for cosines? 1 and 2. So, where in that blue region am I hitting cosine being a -1? At pi. That's it. That's all we're doing with this first one.